So my name's Ian Bellamy. I'm a technical specialist for Jacobs, and well, thanks for coming to my presentation. All roads lead to InfraWorks 360. I've been using the software for about 3 years, and I'm the primary developer of all the workflows and the tools that we've been using in the program. So basically, I'm going to start by going through what we used to do back on traditional schemes, from optioneering to preliminary design to detailed design, how we use the software, how we go between Civil and InfraWorks. So it's as it says there, in the beginning there were 2D drawings. So traditionally on a scheme, at preliminary design or optioneering, we would have multiple options which would just be lines on a plan. Typically they'd be designed using Arrival software originally. So you'd have an alignment to DMRB. You'd then make that a thick coloured line for the different options. Then that would be put onto a plan, which would then be used to make informed choices as to which one we're taking forward. But with InfraWorks, we can now do something that's a bit better. So we create and import standardised styles. I'm not going to show that today because there are plenty of tutorials online that Autodesk have done themselves. And then using those styles, we can create options similar to the one that you see on the image. And then any changes we want to make, so if we want to change the option, we want to change where it goes, the start and end, we can do that within InfraWorks itself. So here you can see I've got a pre-made model. This was made using Model Builder, and we have existing topographical survey that we have done, and we bring all that in. The tools that we use, if I go to Style Palette, we have materials, which are the same materials we use when creating our 3ds Max visualization models, just to make sure that everything looks the same. And we have a Jacobs Styles folder here. Using the materials, you can then create material groups, which are then used to create the roads. Again, we have a Jacobs one where it's all combined. And then we have a Jacobs roads, which contains just a number of standard roads that we've set up. So what I'm going to do is just draw a road, a highway road. I will choose the Jacobs SMP, which is the smart motorway. So preliminary, but primarily we use this software more for visualization purposes, and primarily on smart motorway projects. So all I would do now is just draw my option out using the DMRB standards. I mean, this is just as an example. Sorry, it's a little bit slow. And as you can see, we have the design there, using the standard we've got with line columns, barriers, white lines. So then if you want to go into a little bit more detail just for your scheme, you can add, say, for example, a bridge. We'll just draw a road going over the top. So in here you can see it's automatically create the junction. Now what we would do is you would go into the vertical profile and do a design. All I'm just going to do just to quickly show you is, so select the road. It's not actually, just choose a different style. So if I go to just drag and drop, it's as easy as that, just to change the style. Can I add it? No. Just delete that, I'll do a standard, just a sketch road. Sketch road over the top. So then here we can go and we need to convert that to a design road. Then in here we can add, why is it not letting me do it? There we go, add a PVI, and we can raise that level. And then from here we can just add a quick bridge just to give it a bit of an example of what it would look like. So just click the start and end. And as easy as that, you have your bridge. And from there you can make changes to make it look however you like. So if you have an existing bridge, you want to make it look like what's on, let's say, Google Maps, you can just go in and make the changes. If you want to remove the number of the pier, you could just put whatever number of pairs you want in there, change the pair. So I'm just going to remove that. And that's the preliminary option. That would then go along with the line on the plan. You could show that to your client and say, this is what your scheme will look like in this area. Which one do you want to go with? So then, if I go back to, I don't know which is my present. Oh, right. So then, once you've done your preliminary design, your optioneering, you know which one you want to take forward. You then go to preliminary design stage. And this is where traditionally we would have just had design models. So they would have been made using string-based tools. So you'd have had an alignment, you'd do offsets with crossfalls, transitions, super elevation, anything you need for the highways alignments. And then from this we would have outputs, which we would create drawings, and then the 3D outputs would be used to create expensive visualizations for the consultations and for the plans using 3ds Max. But with a bit of manipulation of the outputs from the string-based software, we can actually make visualizations using InfraWorks within a matter of weeks rather than months. So that what we do is we take the 2D polylines and create boundaries for each element. So you would have a boundary for the carriageway, a boundary for the centre of reserve, a boundary for the verge. You'd use the 3D polylines to make a surface in Civil 3D. You would then do exports of both of those, import those into InfraWorks, apply styles to them to make it look something like that's on the screen. You could then use the alignment to bring that in and apply a barrier the full length along the centre of the carriageway or any other roadside features you like. And then we can start importing 3D models, so our 3D signs, our 3D road markings, gantries, bridges, anything that you can create a 3D model from, InfraWorks basically will accept. Then once you've done that, you can actually add a bit of vegetation to actually make it look, give it a bit more depth, make it look a bit more real. Now, if I go to, so I've got a bit of video just to speed things up a little bit. So here we have the 2D output from our model. Now, that what we use is I use a command called linework shrink wrap, and all that does is you can select 2 lines, and it will automatically create a boundary from those 2 lines for the full length. So you can see there I've just selected the 2 centre lines to create a centre reserve, and there we go, that's the boundary made using that command. So we do that now for hard strips, carriageways. You can make the whole width of the carriageway one boundary. You can make each carriageway lane separate boundaries depending on whether you want to have the same style applied across the whole width of the carriageway or individual lanes. And then once we've done that, let me just, I think, do another couple more. Oh yeah, the other thing we do is we create a boundary around the whole of the model. So when we create the surface, we can bring that boundary into the surface and trim the triangulation back so everything matches up perfectly. As you can see, once we've done that at the top here, we have layers that show which part of the carriageway, which part of the cross-section, so earthworks, verge, hard strip. They're quite important for when we come into InfraWorks. Basically what that does is once we've done the import, it brings them through and gives you a list of what it is that you're actually importing. And then from this we would use the command map export, create an SDF file. So in here, just for the sake of this, just call it boundaries, just so I know what it's called. Generally, if you're saving all this information on a scheme, you would give it the name and the convention you have in your scheme. Now, I'm manually selecting all the boundaries because you may have more than just the boundaries in the model, but you don't want to export everything, so I select just the boundaries, just making sure that that's all I've selected. And then on the feature class tab, you select create multiple feature classes. So what that does is it creates a class for each layer, and then treat closed boundaries as polygons. So then when we create when we bring the import into InfraWorks, you have the boundaries as polygons as a shapefile so it can read them. So then if I go to, so in here this is my 3D export of the file. So all we would do in here is like with Civil 3D, is we would create a surface, give the surface, I'll just give it any name, so London surface, that'll do. So that's created the surface, but there's nothing in it yet. So what we need to do now is add all our 3D polylines, or if you've got points that you've designed as break lines, give that a bit of a description. So 3D polylines if I could spell, select everything, and then what I will do is I will unselect this boundary because the boundary has no levels on it, and that will affect the surface. And then that should have created, there we go, a triangulation of the surface. Now, sometimes when you create a surface, it may triangulate across here. There are no points there, so we don't want it to do that. I don't know if you could see, but just that bit there. So what it would do is select the boundary that you've created, add that as a boundary, and then that will just trim the surface to the extents of the boundary, which is the extents of our 3D boundaries, the 2D boundaries we've made previously. So then, now I've done that, if I go to, sorry. So you make an IMX export of the surface, you do an SDF, a map export of the boundaries, and then we now bring both of those in. So the first thing we bring in is the IMX, so that's the surface. So once that comes in, you have to configure that. So we configure that at national grid. Just make sure it's at national grid, make sure everything looks okay, and then click close and refresh. So you'll be able to just about see there that the terrain has changed to match our design. So then what we're going to do now is bring the SDF, which is Autodesk shapefile, bring that in as boundaries, and you can see there all the layers are all individual, and you can configure those separately so you can apply different styles to those if you wish. So what I'm going to do now is go through, configure those, make them a coverage area, set the rule style to one of the materials that we've imported originally. So for this, it's the carriageway. Set it to national grid, so it's geolocated, and then make sure that you set the options to drape in the next window. And then what that will do is it'll bring the boundary in, drape it over the surface, and everything will be at the correct levels. So you can see I've done, I think, the same with everything else. And the last one to do is the earthworks, and again, national grid, choose the correct material. And then the good thing about this is once you've done this, you can actually go ahead and start changing those styles if you don't like them or if they want them to look a bit different. So then, next thing we'll do is the alignment. So the alignment that was created as part of the original option, you can bring that in, and then using the road styles that we'd actually created as a rule style, go into the road styles, select the Jacobs one, and I'm going to just create a CSB, which is the concrete central reserve barrier. So everything has to set up correctly. Go close and refresh, and that brings in the barrier. So then, as you can see here, we have a script that was made by one of our programmers that allows us to bring in the white lining. And what we found is, because we use a competitor's product, it's all 3D white lines, 3D road studs, 3D rumble strips at the edge of the carriageway. So we could bring them in as coverage areas, which we could do for the whole length, but we choose not to because we want everything to be 3D. And because InfraWorks takes the curvature of the Earth into account, and none of the other software we use do, we have to split them up into 500-metre sections to account for this. So you can see here, they're all split into 500-metre sections. And then what this script does is it imports them all at the same time. Well, imports them one at a time, configures them, and then all we need to do then is just select them all and refresh. And there will be some white lines appear, but as you can see from the video, they don't all appear. And that's because the white lines created in the software are polyface mesh, and they have two faces. They have a front face and a back face, and InfraWorks only reads really the front face. You can turn an option on to read the back face, but it changes the colour and it looks black. So what we've done is we figured out that changing the orientation of the mesh in the properties brings in the other half. So we then bring the other half in, change the orientation, and save all. And the script again imports them all, inverts the orientation automatically, and then all we have to do is click the refresh button, and that then is the full white lining option done. So then if I go to here, so the signs, again we use a competitor's product to do the signs, and the signs are fully 3D signs with foundations, posts, faces. The issue we have with this is when it brings them in, when they're in place, it creates an FBX. An FBX file doesn't support coordinate systems, so when they come in, they're all distorted and you can't actually read what they say. So what we have to do is, as the designer is placing them, he places them in the location, copies them to another file, places them at 0, 0, with 0 height, 0 x and y, 0 rotation. Takes the schedule that we create for the signs and takes the x, y, z and the rotation of each sign and just places them in a table. We make that into a text file, and then when we run the, I think I've got, yep, so video 8. So when we run the import for the signs, again, we run a script that reads the CAD file, goes and finds the text file, identifies the name on the CAD file, looks for the same name in the text file, and then reads the X, the Y, the Z, and places them in the correct location using the manual placement tool in here. So running through this, this is doing it just at the live speed, just to show you how quick it does the sign. So what that's doing is it's importing them between the X, Y, the Z, doing a close and refresh. And you can see them all starting to appear at the top here. Just give that a couple more minutes just to read. There's only 4 or 5 signs to come in. And we've done the same with gantries. So the gantries, you can bring them in directly from Revit, but at this stage we generally don't have the Revit ones, so we just place what the gantry may look like in the same location, give it the same X, Y, Z, and bring that in as well. So we'll see here, once it brings the last one in, I think that's the last one, you just select them all again, do a refresh, and it places the signs in the correct location, and you're ready to go. So then, the next thing we'll do is, now we've got all our signs in, so if I just change it, we've got our white lines, we've got our signs, we've got our barriers. I just want to make it look a little bit more, give it a little bit more depth, look a little bit more realistic. I don't think I've got the signs in this one, apologies. But basically all we do now is go to standard trees, and we'll just pick a random tree for now, and we can just draw a boundary where we want the trees to go. I'm just going to create a small boundary. So you can see here we've got quite a lot of trees, but they're all the same and they're not necessarily the right style we want. So if I go to style rules, in here you can create a style rule for the trees. Trees 1. So in here you can specify what type of tree you want, just so you can see. I'll specify a yellow one, I'll add a red one, and then we'll just add a nice green one. And then this is the probability of them. So if you want more tree to appear more than, so if you want the red one to be more prominent than the green ones, you just give it a bigger number. So I'm going to make it twice as prominent in the file as the rest. And then click OK. I can commit that and I can run the rules. So that goes and applies the rules to the trees, but you can see nothing's actually happened to the trees, and that's because at the moment, if I zoom in, it has, if I select them all, it has 2 rule styles applied to it. The manual one, which is the one we created at the beginning, and the one that we just created the rule style. So what you need to do is delete the manual one, click the update button, and that changes the tree styles. And then you can just change the height of them, change the density of them if you want, and then there you go, they're your trees along the side of your scheme. So now we've got our preliminary design. We then need to go forward and take that into detailed design. Why is that not? So now, when we go to detailed design, we've got the world of 3D. So with the BIM mandate that the government imposed on the UK, Jacobs decided to do all their highways designs within Civil 3D. And it allowed us to create intelligent 3D models because we could add the data to that, and we could then start exporting the data, moving the data around, clicking on that to get volumes. Then because of that, we started looking at other Autodesk and non-Autodesk tools to create other 3D elements. So as you've seen, we create 3D road signs, we create 3D road markings, we can create the bridges using Revit. And we can create all those in geolocation and then just import those directly into the model without doing much manipulation other than the signs. So we're not sure whether there's going to be a resolution for that or not. And then, as you can see, you just start to add more and more and more detail. And going forward from the optioneer into the detailed design, it doesn't actually look that much different. There's just more detail in there. So we have to prepare our Civil 3D models to be just directly imported in. That's taken care of with a template. I'll then take you through how we import our models. So you can see here we've got extra communications, cabinets and CCTV masts, signs, road lighting, sorry. Then we can create animated objects. So the cars in this model are animated and they're using 3ds Max. We just create them in 3ds Max, export them out, import them in. We can then create a camera path and then we can edit and export the animation just so we can use those to do checks, to just show the client what it will look like. So what I'll show you now is, so we've got a traditional 3D model, several 3D. So generally on the smart motorways, we design the northbound and the southbound, or the eastbound and westbound, on separate models just to keep the file size down. And we have, within Jacobs, made our own set of sub-assemblies that we use on every scheme. So you can see here, if I go into the sub-assembly properties, you have a code at the bottom, which is central reservation. So these codes are very important. These need to be named a specific way, and I'll show you where that's labelled, and so we know what to name them. And that's, again, the same with the carriageway. You go down, you've got pavement code of pave. I just found one that's got earthworks and a verge. So then you have the verge. If I go to the sub-assembly properties, and down here you have a code of verge. And again, just to show you for finality, you have one here called earthworks. So then once we've checked all those are set up and we've built the corridor, we need to build a corridor surface. So in here you can see I have two surfaces. This one is a corridor surface. We don't have to do any exports from this. We can bring this model directly into InfraWorks. So if I play the next video. So in here we go to style rules. And you can see for the road, you've got this list here that says tag. So this is the important bit. So within our template, those pavement codes need to be named exactly as we've got in the template. And then in here, these expressions need to be named exactly the same as our pavement codes. The codes in Civil 3D, the link codes, and the same with this name. They all need to be named exactly the same. So what I'm doing here is I'm creating a new style just to show you how it's done. So you create the expression tag equals verge. And so if I click commit, that's that ready to go. So we do that before we actually import anything. And then from here you can just import the Civil 3D model directly. So if I click the one that we've just looked at, so that will bring up this list. So in here you can see it's got everything that's in there. If we untick this surface, because we don't need the existing surface at the moment, and it's brought in an alignment, a terrain, and some coverage areas. So as we did previously, set the terrain model to national grid, and close and refresh. And this is effectively doing the automatic version of what we did manually, using the 2D polylines and the 3D polylines. So you can see there, we have the surface brought in. So if I just rotate round, we then go to the coverage areas. So this is the important bit. We don't change the rule style this time, we'll leave that as is. We'll make sure, if we have more than one corridor, you select the right corridor you want to import. Make sure that this tag is set to tag, and the source was set to drape. And once you run that, it automatically picks up the styles, and you're ready to go. But as you can see here, the central reserve is missing. It's highlighted, I can highlight it, but it's missing. It's not picked up the tag. And that's because what I did is, you can see here it's made a new tag, and I can just apply a style to it, and then that will read that. But I don't want to do that. I want to make sure that the ones that we're using as a standard are named correctly. So I need to go in here, and what I've done incorrect here is I've named this central reserve rather than central reservation. So I got this correct, but this top one wasn't correct. We change that now, and then click commit, and then run the rules again. It automatically picks up that I've now changed the name. Sorry, I'll just run the rules. You can see there, that's the central reserve. So the next thing we do is, again, I'm only going to do the 1/2, bring the alignment in, make sure that we select the right alignment, national grid, choose the rule style. Again, we'll choose the Jacobs one. And there we go, that's that done. So as you can see, the process throughout every stage is basically the same. It's just the further along you get and the more detailed you get, the easier it becomes. So now what we're doing is, you can see we have feature lines along the centre of each of those carriageway lanes. And these feature lines are going to be used to import into 3ds Max and create the path of the vehicle. So as you can see, you might not be able to see, but there's a green triangle that dictates the direction the string is going. And they need to be going in the exact direction that you want your cars to go. The next thing we need to do is make sure that we have levels. So you can see here there are no levels on this. If I click the add levels by surface, because there is only one surface, it automatically picks the levels of that surface and just applies it and drapes it along the surface along the whole length. So then, once we've done the northbound, go through and just check that the others actually have been done. Then we need to do the same with the southbound. So again, select one of your strings, go to the level editor, and then just make sure by clicking on the points that you can see this green triangle, it moves down. It's a bit hard to see in the light, so apologies for that. So the next thing we do, once we've got all that correct, you just go to Output, Export to 3ds Max. We don't want to export the surface, we just want to export the sites, because that's where the feature lines are stored. And that creates a VSP 3D file that 3ds Max reads as a geometry. So if I just save that, that's the file created. So that's everything we need to do in Civil 3D. We now need to go to 3ds Max. So we're in 3ds Max now. First thing you do is start Civil View. I mean, I'm not a 3ds Max user, so anyone can do this. This is very basic. I taught myself to do this quite quickly. So if you go to the Civil View and the Geometry Importer and go and find the VSP 3D file that you've just made, you can see here it brings each feature line in individually. I've named them so I know which lane is which. Click Apply. So this is very important. You need to make a note of the X and the Y coordinates there, because what 3ds Max does is when you do an import, it shifts everything as close to 0, 0 as it can. And that's the shift that is applied to the X and Y coordinates. So you need to make sure you make a note of those. So as you can see here, we have the same polylines or feature lines that were in InfraWorks, Civil 3D. Go back to Civil View and go to the Object Placement Editor. New object, the parent shape is the feature line. So what that does is it reads the feature line. You tell it to just pick all the cars that are in there at random stations. So basically we want them randomly spaced out, and you choose how many we want. So for this I've just clicked 25. You set the speed. So generally, just to make it look a bit more realistic, I set the speeds lower in the inside lanes and higher in the outside lanes, because that's generally how people drive in the UK. So you can see there that there was an error that came up saying that the length of this at the bottom, which is the animation, wasn't long enough for the amount of cars that we have. And it's automatically extended that. But what will happen is once it gets to 1,000, the cars will stop animating, but the animation will continue to run until the end, which is not what we want. So let me just delete that. So if you delete everything that you've done in there, go to the time configuration at the bottom and just change the length of the animation to something that you know is longer than what you need. So I want to pick 4,000 because it said 2,000, so I've just doubled the length. And then run this again. So select your line, run it again. So what that will do now is it'll create the cars and animate them for the full 4,000 animation length. We don't want it for the full length, so what I'm going to do now select the first car, automatically, manually animate the car through the whole length and wait for the car to reappear back at the beginning. And what I will do then is, once I've highlighted where at the beginning the car is, what the length is on here, we can then trim this back to that location, and then when imported, the cars will be on a continuous loop. So it would just continuously loop and not jump around. So you can see there, that's got 2,300. Go back to the time configuration. Go to change that to 2,300, so that's shortened this. And then if I just go back to the end, you can see the car comes through and this continues to animate up the road. So the next thing to do from here is to export the animation ready for use. So we export this as a .dae file, Autodesk Collada file. Select where you want to save this, just so it's available for everyone. Give it a name, again, give it something sensible. So then the important bit in here, this is what I've been told by our visualization team, is this option here, bake animation. If you don't bake the animation will not export. So make sure the bake animation is ticked before you actually do before you go any further, and then just click OK. And you can see here, it's resampling the cars, doing the export. So the export's now done. It's been clipped just to speed it up. You can see there are a few errors, and that's just saying it can't export these feature lines. This is saying that some of the materials it can't export. So it will look it may look a bit strange when you import them. But it's generally fine for what we do. So now we go back to the import, and you want to be importing 3D model. So now go to the location your cars are saved, select your .dae file, click open. So that will bring the cars in ready to configure. Now this is where you need to remember the X and Y coordinates that that 3ds Max told you. So set national grid, remove the negative from the coordinates and replace them in the X and the Y here. So I'm just typing out what it said. One thing to note is when working in 3ds Max, we've found that we have a similar issue as with the white lining, so we try to limit the length of each animation for the cars to about a kilometre. This is generally the full length of this is a kilometre. So on the larger schemes, if like 8, 9, 10 kilometres, you have up to 10 different files. So as you can see, the cars are now animating in there. We'll just do the import again for the other carriageway. So I'm just choosing the right. You can choose any of the styles. I just add them as city furniture because it's just the most obvious thing I could find. Put the same offset again. Close and refresh. So you now have, when it loads, animated cars on both sides of the carriageway, which makes the model look a little bit more realistic. On this, I turned the trees off. Having the trees the full length, the width we have, it actually takes quite a lot of processing power. So it's generally good to have them switched off when you're doing the imports. So the next thing I want to show is our camera path. So all I've done here is, you can't really see, but if I highlight that, I've taken one of the feature lines that we made for the cars along one of the centre of the lanes. So you just decide which lane you want to run your animation along. You can actually do animations as a flyover at the top, but generally for the smart motorways, we run them at carriageway level as you're sat in the car. So what we need to do now is if you explode the feature line, so you then ended with a polyline, 3D polyline, what you can do is you can weed those if you want to reduce the amount of points. So the more points you have, the more key frames will be added in the animation. You'll understand what the key frames are if you've never done it before once I get into InfraWorks. So the next thing to do is to go create point group. So in here, make sure that under point creation, this is set to eastings and northing. Sometimes that switches around to northing and easting. In the UK, we use easting and northing. If you're in a different country, just use whichever coordinate system you use. The grid coordinates, I'll just leave that as it is. So these ones, prompt level, prompt for name, prompt for descriptions, click none. And what that will do is that will read the point group, the point names, the point numbers that we tell it to read when we do the import. So then the next thing you do is you go to polyline vertices automatic, select your line, and then what that will do is it will create points along the whole length of this line. Then to get that out, you do output, export to Civil SDF, select the location you want to. So this is a slightly different XSDF to the map export, but it still uses the same file type. Select where you want to put that, click OK. And if I go back to InfraWorks, I'll just go to the finished article, name enough. It might take a little bit of time to load with it being quite big. Apologies, just give it 2 minutes. Right, okay, so while this is loading, what I'll do is show you what we do. So go to this button here at the top, which is the create and conduct infrastructure presentations, storyboard creator. So in here you can see I've already got a camera path, which is the one I'll use because I'm not going to do the import. It'll take quite a while. But to do the import, select this button here and click import camera path. So this will read the SDF shapefile, whatever kind of file you choose to make. So for this I just used an SDF animation path. Click open. I won't do that, it takes a while. And then what that does is it creates this animation path here. So each one of those, you can see I'm highlighting there, was one of the points on your line. So as you can see there, because I had a lot of points, it's brought in a lot of keyframes. So if I click go to location, it will skip to that location. So what it does is it places a keyframe at every point and then animates, renders between them. So then what you can also do is you can add titles by using this function here. You click add new title, this box appears and you can type in there anything you like. So if I go back to the beginning of this and click play, what that will do is it brings up the title and then starts to animate. What you can also do is if I animate through and find, say, gantry. So in here, identify this gantry. We want in the model, in the animation, we want to give that a name so people know what the name of that gantry is. You can add. Sorry, just drag that along to the correct location. If you take a note of the number, you can change the time in there. So in here, if I just put and that's chainage, I don't know, it's just anything, and I go back to here. If I click play now, what that will do is it'll bring up the name on there. So then as you play in the video, you do the export. When people are watching the video, they can actually see the gantries, and then they can look. We take these to safety meetings, and the safety auditors look at that and think, actually, no, we can't see that, or there's too short a distance between those gantries. This sign's in the wrong place. Can we move these signs? This tree is, you know, I know it's not real, but the tree is obscuring the sign. And then to do the export, if you click this button here, which is export storyboard, we tend to use Windows Media Video. Use the advanced one, change the bitrate to quite a high bitrate. So this makes the video better in quality, bigger in file size, but doesn't actually change the export time. Untick a keep aspect ratio. So generally the screens we use are full 1080p HD. So if we go 1920 by 1080, that will export at full HD size. If you click record, that will then go away and do the animation, record it. It could take an hour, could take a couple of hours, might take 30 minutes, depends on the size of your file. And then if I just go into here, go to animation. So this is just an example of what we made. So the animation, it just runs along this is slightly above the car level, but it just runs along at car level, and as you can see, see the gantries, you can see the cars, you can see the lines, any signs that are in there. And it's ready to go. So, is there any questions you have about anything you've seen in there? And we have a microphone if you need to ask a question. Just turn over there. Do you want to go that one first then, sorry.
Can you bring in the road markings from other softwares?
We haven't tried other software, but as long as you can make them a 3D face, 3D mesh, then yes, you can bring them in.
The question is on the signboards. When you're having, you haven't shown any text on that, but when we actually do the signboard, the one we are seeing in InfraWorks, is it a 3D solid, or how are you importing it?
Again, I think that is, it could be a 3D solid, but I think that could be a 3D face, a 3D mesh again. So they have, rather than the sign and the text being flush, the text actually has a height that's a mesh, and InfraWorks reads that mesh and reads the colours, and actually when it brings it in, it applies the same textures to it as you would see when you click a realistic view in
because
software.
We had similar problems actually. If there is no gap when we are trying to do the visualization, there is a color bleeding that happens when we are running through. So we are trying to make it into only solids so that it is useful in visualization as well as for any clash detection also.
Yeah, that was an issue we had. We worked with the software vendor we used to resolve that issue. We basically said that it would be better if we could have them kind of set a width, so it could be 200 mil, 150 mil, 100 mil, to extrude from the sign face. Because we were having the issues when we brought that into InfraWorks to do the clash detection, that we were having the bleed through as well, and we couldn't actually see them, so that's what we had them do.
Just one more on road markings. You showed that you're trying to read the files as polyface meshes. Is it like it is you're trying to have the boundaries and drape it onto the surface, or how is it?
Yeah, that is an easy way of doing it.
Yeah.
But our road markings have a depth to them, so it has the actual depth. Yeah. If you have the ribs on the edge of the carriageway, it has the ribs in there. As you can see there, maybe it's got the actual road studs, and the road studs have the colours on them. And as they're designed that way, when we bring them in, it actually shows them, so it looks more realistic for this. But you can bring them in as coverage areas. It's just we choose to do it the way we've done it in this.
So the one you showed, it is customized for, I mean, the files that were running in the background, that is customized for Jacobs, or is it available?
Yeah, it was an internal developer that wrote that script, yeah. Right. But it's just a standard, I think it was C# he used or something like that to write it. So.
Yeah, the VBA. Thanks.
Okay. Any more questions, or is that? Right, thank you very much for coming. I hope you at least learned one thing today, so that's good, thank you.